Hello and welcome to another session, and in this session I'm going to show you the power of parallel stream and when exactly we should use parallel stream in Java. So here are some data points from an experiment which I carried out. Like if we try to add up numbers from 1 till 10 million, the for loop takes, the very simple for loop, the vanilla for loop in Java takes 121 milliseconds. A sequential stream takes 116 milliseconds and a parallel stream takes 14 milliseconds. So you can understand the power of parallel stream. The more the data volume is, you will see that the parallel stream is much faster. And if the computation is more intensive, then also you can see the power of parallel stream. So let's go ahead and now see the demo of this particular experiment in action. So let us go ahead and see the demo. Again, please go to my GitHub repo, which is github.com/mshomik78, and then to this particular repo, high-level code.java, and there let us navigate to the branch parallel stream demo, and I have written the instructions very clearly, so you can clone the branch. And actually Maven is not required because it only involves core Java, but I always use Maven for any project because in case we want to experiment with any other external library, we can easily add it. So I will now open IntelliJ. So here is the program. So what I'm doing here is, like, we are summing numbers from 1 to 1 million first using a simple for loop, which is this, and then using a sequential stream, and then using a parallel stream. So, and then for every single operation, I'm iterating it 10 times and taking the total time taken for 10 such iterations. So let us now go ahead. So I think this is 10 million. Yes, this is 10 million. So let us go ahead and run the program and see the output live. So the time taken in for loop is 65 for 10 iterations, remember it. And this is 74 for sequential stream, and for parallel stream it's 15. Now we will see if we reduce it to, say, for example, 10,000, then we will see the difference. Then let's run that and see the difference. So as expected, the for loop was much faster. The sequential stream is much slower, and the parallel stream is slightly faster than sequential stream, but it's still much slower than than for loop. So why this behavior? This is because of the fact that a parallel stream, or for that matter, a stream operation is only more performant when there is a substantial amount of data, because otherwise it has some kind of overhead to actually set up the stream operations. So unless and until we start with, say, at least 1 million records, I will never see a sequential stream operation to be more performant than a for loop. So with increase of data set, then the parallel stream will become even more efficient, even more performant than the sequential stream. And the difference between parallel stream and the sequential stream will be even more evident if I increase the amount of data set and if the computations are more intensive, like if I try to encrypt something, if I try to create a hash using a difficult algorithm. So for all the scenarios, like when the computation would be intensive, as well as there's a huge amount of data, the parallel stream will be always faster than sequential stream. So I hope that demo is clear and it is insightful. So thank you for your patience and time if you're still here along with me. And I hope you have been impressed by the power of the parallel stream and when to use it. When there is a huge amount of data set, then parallel stream definitely makes a lot of sense. But if you like my session, if you like the explanation, consider subscribing to my channel for such interesting sessions. Whatever I get to learn, whatever I find interesting, I always try to share here. Thank you for your time again, and bye-bye.